So your mic is mute.
Okay, Mike. Okay, so let's begin with the today's session, and what we have discussed up to this lecture is all about timer. Okay, so we know that there are two timers, timer 0 and timer 1, and you can operate this both timer in three different modes that you know as of now, that is mode 0, mode 1 and mode 2. If you want to mode like name the mode 0, it's a 13-bit mode. Your mode 1 is 8-bit but auto reload. Okay, so the name itself is 8-bit auto reload mode, and mode 2 is a 16-bit mode. You know how to calculate for these modes, and now you also know how to program this two timer using two methods. The method is pooling method, and the other one is interrupt method. So up to this point, we know, like we can program up to this point. So now what we are going to do is up to this moment we were dealing with a time delays. Okay, so the programs were like where you have to generate some specific time delay, like 10 microsecond, 20 microsecond, or 1000 microsecond, or even a 1 second time delay we have generated. Now this timer can be operated as counter as well. Okay, what does that mean? That means you can count the events happening around you. How you can do that? So for an example, if you want to count, let's say this is a classroom, okay, and on the door, okay, let's say this is a door here, and on the door I have a sensor. Which sensor, I'm not discussing about that, but I have a sensor. What does this sensor do? Whenever a student enters here, it triggers a pulse like this. Okay. So now using this timer, you can count these pulses. So what can I basically do is I can count the number of students entering into the class. How I can do that? I can do that using uh, timer itself. So timer is going to work as a counter. So how you can do that? So obviously this sensor is a hardware thing, and that means this is a separate device. A sensor is a separate device. So basically you are going to connect your sensor to your 8051 somehow. Okay, how we are going to see how like where we should be connecting that sensor, but this is the scenario. I'm going to connect that sensor to my 8051. Okay, so basically whenever you want your timer to be operated as a counter, this is my timer, I want it to be operated as a counter. So the first thing is that whenever you are operating in counter mode, you are counting some external event. Okay, like there is no inbuilt sensor inside 8051 which can have this kind of pulses generated when a student enters in the class. So you are going to connect an external hardware for that. So whenever you are operating your timer as a counter, you will be having some external hardware connected to 8051. Okay, and you are going to uh, calculate, or rather count, an event occurring outside 8051. Okay, so here in our example, the event is occurring in real life is where in my classroom entrance. What is happening whenever a student is crossing the gate? At that time a pulse is generated. Okay, so for example, first student enters, so my false pulse will be there. After some time, second student enter, one more student, third student, fourth, fifth student, no entry. Then after some time, so this kind of event can be calculated with my counter. So if this many number of student enter, what will happen? With each pulse, I have to like count this each pulse. So when we have studied the timer, at that time I have told you this register TH and TL, Whenever you provide a pulse to this register, it will increment it by 1. So what I'm going to do now, I'm directly going to provide this signal over here to this timer. So what will happen? This is the first instance, so my register will increment to 1, 2, 3, 4, 5 and 6. So now if you look at this closely, again this is the same kind of signal. The only difference is that the previous signal that we were inputting to timer was frequency, or rather a periodic signal which can be defined over a frequency. But now the signal is random, but again you can see this similar type of observation. What is that observation? A pulse is occurring after some time. Then I'm calculating that pulse number of pulses occurring outside 8051. That's the scenario. Okay, so this is how my counter is work. So everything is same, like operation mode of operations are same, pooling interrupt methods are same. The only difference is that rather than taking the input, okay, so what we were doing in your timer was oscillator division by 12, and then there is a gate which can control your timer, and then what I am having was here TH and TL. So my input to TH and TL was rhythmic, or a frequency rather, or a periodic wave in that case. Now what I'm going to do? Now I'm going to add one more switch over here, and using the switch I'm going to move my position from this position to this position. And what is this position? This position is basically an external input. This is my external input. Where my external input will be coming from? That input will be coming from a T pin. Okay. Let us say it is a TN pin. So there are two pins basically. There is T0 and T1. We have seen this two T0 and T1 pin in our hardware. Okay. I am going to show it to you again where the pins are located. These are the two pins. If you go to port 3 is multifunctional port, and here you can see your pin T0 and your pin T1. So these two pins are the external pin where I am going to connect some external device, and using that device I am going to count the event occurring outside my 805. So basically the sensor that I was talking about to count the number of students entering into the class is going to connect it on either pin T0 or pin T1. Okay. If I connect it to pin T0, that means I am operating my timer 0. If I connect it on pin T1, that means I am operating my timer 1. That's the only difference. Okay. So now let's take an example, and let's before going to example, let's see the diagram of timer, and what are the changes that are going to happen. Let's see that. Okay. So this is your timer diagram. Okay. I'm not discussing whether it's a 8-bit or 16-bit or 13-bit mode. The only change will be here. We know that already. But where I'm interested right now is this part. So up to now, what we were doing, we were making C oblique T bar. This is the bit of T mode register. We are making it 0. So what was happening? We are feeding our timer from this oscillator. But what I'm going to do now is I'm going to write this bit C oblique T bar to be 1. So immediately this switch here will be connected to this pin. And if you closely look at this pin, this is a TN pin. Okay, a pin itself is written here. That means this is the 8051 pin. Okay, the hardware pin on your IC. So I'm going to connect some device over there, and if a pulses appear on this pin, automatically that pulse will come inside here, and the content of TL and TH will be incremented here. So this is the only difference. Otherwise, all the functionality will be same. The only thing is that rather than having some time delay, now I am counting some events, and as we are counting the events, the problem will be more easy now. For example, if I say 1000 microsecond, in that case you have to calculate something, and then you get some numbers, and you are going to feed that number in this register. Now what we are going to do, now we will directly have that number. We just have to calculate the hex number, respective hex number, which we are going to put in here. Okay. So let's see with an example how to program a timer, rather a counter. I'll go with one program and the other two programs will be, you have to do that two programs as a homework. I'll check it tomorrow morning. Okay. So you have to submit it tomorrow morning. Now let's see the program. Let's say the question is write a C program, uh, right? Let's have some different kind. A sensor is connected on conveyor belt. Conveyor belt is carrying uh, you have to packaging machine bottle of so basically what is that? There is a conveyor belt. Conveyor belt is carrying a bottle and your packaging machine is that. So packaging machine is like having 100 bunch of bottles. So once you receive the 100 bottles, you have to again start counting and send the pulse to the packaging machine, like the 100 bottle is done. Okay. So you have to write a program for that. So write a C program. The question looks like a very complex question, but it's a very simple question. Write a C program to count 100 bottles and 100 bottles and send a signal once 100 bottle process are received packaging machine. Okay. So this is your question. A sensor is connected to conveyor belt. Conveyor belt is carrying a bottle. Packaging machine is packaging bottle of like 100 bottle of a bunch. Write a C program to count 100 bottles. So what you have to do basically, once you receive the 100 bottles, you have to send a packaging machine that a signal like 100 bottles is, and now you can pack. Okay, and then what you have to do, you have to start again with a zero. Okay, you have to repeat this task continuously. So you have to start with zero again. So now let's see how this program can be done. So basically what you need is 100 bottles. So once you receive the 100 bottles, what it should be doing? It should be receiving a signal. So let's see an example like how it is connected. Uh, so whenever this kind of question is there, first line you have to write is, let's assume a sensor is connected to pin T0 or T1. Let us say T1. Okay. Pin T1 of 8051. This is my assumption. If the data is not provided, then you have to assume this. Otherwise, what can I do is I can even do this. A sensor is connected on pin T1 of 8051. I can do that on pin T1 of 8051. Okay. So now the additional information is given here. If a T1 is given, that means I have to use timer 1. Okay, that's the information. So you have to keep, like, you have to closely monitor the question, because sometimes some hints are given in the question itself, and if you program this with T0, I'll cut the marks. Although your program would be correct, but I'll cut the mark. Why? Because you do not have focused on this statement, pin T1 of 801. Okay. So if it is given like that, that's okay. Then you do not have to write it like this. But if it's not given, you have to take an assumption and then you can start your program. Okay. So now, what arrangement is that? Like, let's assume this. There is a one conveyor belt like this. Okay. It is like bottle is coming from this side somehow. I'm not discussing how the bottle is coming in. So this kind of bottles are coming in, and I have a sensor somewhere over here. Let us say this is my sensor. So whenever, like, this conveyor belt is constantly moving, so at some point of time this bottle will reach here and it will cross this path. So whenever it crosses this path, I will generate a pulse like this. Now if I draw a graph versus time and my, like, let us say bottle or a sensor input, so sensor input will produce a pulse each time a bottle is in front of it. Okay, which kind of sensor this can be? Can anyone assume the kind of sensor? Which kind of sensor this can be? Okay, you should look for which kind of sensors available in the market. Okay, because when you go to industry, no one is going to tell you like which sensor you want to use. They will just assign you a task and then you have to do all the things by yourself. Okay, there are lot of number of like lot number of sensors available in the market, and generally whenever you are dealing with object detection, okay, I'm just saying the word object detection, not identifying, just detection whether there is an object or not. Which kind of sensor you use?
For PIR motion sensor.
It can be an option, PIR motion sensor, but the issue with PIR motion sensor is that it basically works on the infrared light. Okay.
So ultrasonic sensor.
Ultrasonic can work, but the purpose of ultrasonic is different. Whenever you talk about ultrasonic, it's related something with distance. I do not need distance. I do not need a motion. What I need is something else.
Sir, laser sensor.
The sensor can be an option, correct? Other than that, okay. Anyone have ever made a line following car?
Yes, sir.
What kind of sensor you use there?
IR sensor.
IR sensor.
IR sensor.
The IR sensor is the correct sensor. Why? Because it does not detect the distance. It just detects reflecting light. Like it has an LED inside. Infrared LED is there. It throws the light, and if it come back, then it is going to produce this kind of pulse. Yeah, it is going to produce this kind of pulse. Otherwise, it will be flat. Okay. So IR sensor is the first option, and the other one is proximity. Basically, proximity is like advanced kind of IR sensor. So this proximity is like comes in the ready-made module. So proximity sensor or IR sensor can be used for this purpose. Okay. So let's assume there is a IR sensor because we know what is IR sensor. So there is a IR sensor on the conveyor belt, and that IR sensor is connected to my pin of 8051. Which pin? If you want to count something, if you have to count something, then it must be connected to pin T0 or T1. That's only option, either on this pin or this pin. If it is connected anywhere else, then it won't work. So you have to connect on either pin T0 or either pin T1. That's the only two option available with us. Now let's say I have connected pin T1. Okay, so this is my pin T1 of 8051, and I have connected a sensor over there. We are going to discuss how to connect this sensor when we come to chapter of application. We'll see how we can connect this kind of sensor to 8051. It's very easy. But right now we are not discussing into that because I want to focus on timer. Okay, so let's say somehow it is connected like this. So what will happen? As time goes, some bottle will come in front of this sensor. Whenever bottle is there, it will produce this kind of pulse. Okay. Now, as time goes, again one more bottle can appear, a pulse like this. Now, if you look at this, this is directly connected to 8051. That means this signal is also feeding to your 8051. And using my timer, what I'm going to do, I'm going to make the one bit C oblique T bar to be 1. That means what will happen? Your timer will be working as counter. Like I say working as counter. How? Because it is the signal is coming from here T1 pin and it is directly going to your timer register bit or timer register. So what will happen on each of this pulse? Your timer register will be incremented by 1. We know that. We already know that. We have studied that. Now what's my target? I want to count 100. Okay. I want to count 100 and then I have to trigger some action. Which action I have to trigger? I have to let the packaging machine know. So what does that mean? That means from 8051 there is a packaging machine like this and I have to send a signal to packaging machine. So what kind of signal it would be? In most of the cases it would be just a pulse like this. Okay, you just have to send a pulse. Okay, so what you can do is you can send LED is equal to 1 and then make LED equal to 0 again. That's the pulse. Okay, so what you have to do basically you have to just send a pulse. So it's like on packaging machine, like what it will understand from that. But this is just one example question. Okay, I'm not going to design a system. So we can say I can give a pulse to packaging machine. Okay, so each time you receive 100 bottles, you have to trigger an action. Which action? You have to send a pulse to LED. So not LED, packaging machine. Okay, that's the trigger action. That means whenever you generate, like whenever you have 100 bottle, you have to generate a signal for that. That 100 bottle are received. So how we are going to generate that signal? Same principle. See, same principle. Which principle? As this is a smaller number than 255, I'm going to use mode 1, or you can say 8-bit auto reload mode, and I'm going to program my 8051 timer in 8-bit auto reload mode. So how this thing will work? So I'll get a number inside my counter, that is 155. Okay, and this number will go in TH and TL. Obviously a hex version of this. Okay, so I have to convert it to hex. A hex number of this version will go inside my TH and TL. Let's calculate the hex number. It is 9B. Okay, so 0x9B will be going to TH and TL. So what will happen to this number? So each time a pulse will coming on, this number will increment 9A, 9C, 9D, 9E, 9F, so on and so forth. That means we'll starting from 155. After 100, I'll reach 255. Okay, and I'll be generating an signal that will that we can use. Okay, which signal? That is timer overflow flag. So after each 100, you will get a signal that is a timer overflow flag, and using that signal, you can know that okay, 100 bottles are received. Now what I have to do? I have to send a signal to packaging machine. So this is the concept of the program. Now we are going to write a program, but before the writing the program, let's understand the content of various register. What should we write in T mode and T conc? Okay, so T mode is basically your gate, your C oblique T bar, your M1 and M0, and repeat of that same thing over here. But this part is for timer 0, so I'm not writing it, but I'm interested here. No one has said you like whether you want to control your timer from outside or inside. So obviously I'll go with software start method. I'll go with a timer as a counter, so I have to write 1 over here now. Okay, C oblique T bar, you have to write 1. Why? Because I want my timer to be operated as a counter. Mode 1 and mode 0. What I'm going to do with mode 1 and mode 0? Obviously I have selected 255 mode 1. That means I have to select mode 1. Okay, so this is the number and all other 4 are 0. Why? Because I'm not using timer 0. This is part of timer 1. Okay, so which number is this? This number is 0101. That is 84214 plus 1 5. So 0x50 is the number. I have to write T mode equal to 0x50. What about Tcon? So we obviously not using Tcon as a thing, but instead of that we are directly writing TR1 equal to 1. What is TR1? TR1 is timer run bit of your timer 1. Where is that located? That is this bit. So if you make this one and your gate is 0, that means whenever this bit is 1, your timer resistor will receive this signal from either oscillator or your counter pin. This is known as counter pin. Okay, T0 or T1 is known as counter pin. So if you put some pulses on this pin, this will be incremented. Okay, we are going to see that. But before that, okay, let's see that first. So what I'm going to do, I'm going to have include the writing line indirectly and I need this part. What I'm doing now, see, just I'm writing here 50. I'm not doing anything else. I'm going to run this program. So F7, control F5. Okay. 50. That means which timer I have used? I have used timer 1. Okay. So which pin? So I'll go to the pin diagram. I'll show you how this thing works. See, this is pin. This is pin T1. Where T1 is located on P3.5. That means I have connected my sensor on P3.5. Okay. So now let's see that how this will work. Okay. I'm going to run this code. I'm pressing F5. You'll see nothing. Okay. The only change you have seen is this. Here it is written as a counter. No other changes are there. Now what I'm going to do? I'm going to open my port 3. Why port 3? Because my signal is should come from port 3. Which pin? P3.5. See, I have not defined any pin. This is A4. Okay, let me remove that first. Otherwise, you will get confused. Okay. See, I am not declaring any pin over here. And I am running this thing. You can see TH and TL contained.
/pause.
Okay, you can see this contain TH and TL. It is right now 00. What I'm going to do, I'm going to give a signal from pin P3.5. So this is P3.0, P3.1, P3.2, P3.3, P3.4, and this one is P3.5. So whenever a pulse is appearing over here, your TH and TL should be incremented. See, this is 0 right now, and I'm making it 1. Okay, why nothing is happening? Because we have not run the timer. You have to run the timer. Okay. Why? See, the thing is that you are giving your pulse. That's fine. Okay. See, you are giving your pulse from here. You are giving your pulse from here, but this switch is not closed yet. Okay, because I am not running the timer. So I have to run the timer, and then my program will work. So I'll run the timer. TR1 equal to 1. That's the way I run my timer. I'm going back inside and I'll run this code again. Zoom in. Okay, still you can see still the content is not incremented. When it will increment? Whenever you get a pulse wave. Okay, a falling edge will increment your. See, this is incrementing. See, again I'm going to provide a pulse. Okay, whenever it falls, like falling edge will trigger the counter. Okay, see, again it will fall, it will count. Right now it is 3. I am sending a falling edge signal, so it is 4, 5, 6. So you can see this is counting the event occurring on pin P3.5. Okay, so this is how your counter works. Whenever a signal, external signal appears on the pin T0 or T1, that is P3.4 or P3.5, your timer will work as a counter. Like if you have to select that option, And whenever it is working in counter mode, your timer register will increment it by 1 on each falling edge on your pin 3.4 or pin 3.5. Which are the two pins? That are pin T0 and T1. Okay. Any doubts up to this point? Now I'm going to write a program straight away. Any doubts? Okay, then let me complete the program. So what we need is 100 bottles. So I have to. Yeah, sorry, just a moment, just a moment. Let me come to the screen. Yeah, go ahead. Who is that?
સર 28 નંબર પાર્થ ફરીથી
Yes,
કરાવો ને.
ફરીથી સમજાવો એકવાર. પણ ક્યાંથી સમજાવું?
અમને જાતે ઠીક લાગે તમે કરો.
સોરી. પાર્થ મને સમજાયું નહીં તારે શું કહેવું છે મને.
સ્ટાર્ટિંગ થી સર.
સ્ટાર્ટિંગ થી. તું લેટ આવ્યો તો કે પહેલાથી આવેલો?
હા સર. સર પહેલાથી આવ્યો તો પણ કઈ ખબર જ નથી પડી.
એટલે શું ખબર નથી પડતી મને? ટાર્ગેટ ખબર નહીં પડતી. Please leave. Okay, anyone have any other one have a problem? Yes, Parth, you are back again. Parth?
હેલો.
Yes, Parth, go ahead.
હા સર હું એવું કહેવા માંગુ છું કે સર આ કોડિંગ ને પછી એ બધું થઈ જાય તો સર મિક્સઅપ થઈ જાય તો કઈ સમજ નથી પડી રહી સર.
પણ મને એવો ક્વેશ્ચન છે ફર્સ્ટ કે તને શું સમજણ નથી પડતી? લાઈક તને મેં જે કેલ્ક્યુલેશન કરાવ્યું એ સમજણ ના પડી? જો ફર્સ્ટ છે ને ક્વેશ્ચન સમજણ ના પડી એવું હોઈ શકે. સેકન્ડલી જે આ અહીંયા જે થઈ રહ્યું છે લાઈક કન્વેયર પર બોટલ જાય છે ને દેન આઈ રિસીવ અ સિગ્નલ એન્ડ દેન આઈ કાઉન્ટ ધ
બોટલ વાળું તો હું સમજી ગયો કારણ કે બોટલ વાળું તો પેલા એમાં ભણી કંટ્રોલ સિસ્ટમમાં એટલે બોટલ વાળું તો આઈ અન્ડરસ્ટેન્ડ.
ઓકે દેન તને એટલું સમજાઈ ગયું કે પલ્સ મળે આપણને એટલું તો સમજાઈ ગયું ને તને?
હા પણ સર આ તમે કોડિંગ કરો છો ને એમાં કઈ ખબર નહીં પડી રહી કારણ કે કોડિંગ વસ્તુ છે ને બહુ હાર્ડ થઈ જાય છે.
ઓકે તો તને ટાઈમરના કોડ આવડે છે?
સર કહું છું તો કરો સર કોડિંગમાં મને કઈ ખબર નહીં પડી રહી.
વાંધો નહીં પણ તને અત્યાર સુધી જે કરાવ્યું લાઈક આપણે પોર્ટ થી ચાલુ કર્યું ફર્સ્ટ ઇનિશિયલ એલઈડી ટોગલ કરવાનો પ્રોગ્રામ સ્મોલ ડિલે લાર્જ ડિલે દેન વી કેમ બેક ટુ લાઈક ટાઈમર તો એ બધું એટલું તને ત્યાં સુધીનું આવડે છે?
સર જોવું તો ખબર પડે કારણ કે હજી સુધી તો સર એક્સપેરિમેન્ટ બી ચાલુ નહીં કર્યા કારણ કે ખબર જ નહીં પડી રહી કરવા બેસું ને તો સર આઉટપુટ જ નથી આવતું ક્યારેક ક્યારેક ઇનિશિયલ એરર બતાવે.
પાર્થ ક્યાં રહે છે તું?
સર નિકોલ રાવ છું સર.
એટલે અમદાવાદ. વોટ યુ કેન ડુ ઇઝ એકવાર અહીંયા આવજે કોઈ એક દિવસ સિલેક્ટ કરીને મને ટ્રાયલી જણાવજે ક્યારે આવે છે એન્ડ એકવાર ફિઝિકલ આવીને ભણી જતો.
એવું કરું સર?
હા
થેન્ક યુ સર.
બરાબર છે હું તને ફરીથી બધું સમજાઈશ તું ચિંતા ના કરીશ. બટ આ વીકમાં ટ્રાય કરજે અવાય તો.
ચોક્કસ સર.
અને 3-4 કલાકનો ટાઈમ લઈને આવજે. બરોબર છે અને તારી સાથે કોઈને બીજા કોઈને બી શીખવું હોય તો લાઈક પાર્થ વિલ શેર ધી ટાઈમ વિથ મી આઈ પોસ્ટ ધેટ ટાઈમ એન્ડ ઇવન યુ કેન કમ ટુ ધી college no issue in that. Yes Mihir?
Yes sir, I mean I would like to come.
Okay, no issue. Once we decide the time I'll post the time in the teams. So what you can do is you can
I'll coordinate with Path, yeah.
sorry?
I will coordinate with Path.
Yeah,
I know.
coordinate. Anyone else who want to join us? Okay. Who is that? Dhairya and Yash. Okay, you can. Everyone can come, no issue. Okay, so many people. Sushin is there. Okay, then I should be decide. I should be one who decide the time. Okay, I'll decide the time and I'll let you know the time. Okay, we can do one more thing. Like if so many people are there, then we can go with like hands-on like hands-on as well. So what you can do is you can come for 2 days. Probably you are free on Saturday or Friday?
No.
Yes, sir.
Madam,
Sir, Friday.
Friday lab session. લેક્ચર પતી જાય પછી લેક્ચર પતી જાય પછી લેબ સેશન હોય કે નથી હોતા?
સર ફ્રાઈડે ના હોય છે, ટ્યુઝડે ના ફ્રી હોય છે.
ટ્યુઝડે ના ક્યાંથી ફ્રી હોય?
ટ્યુઝડે અરાઉન્ડ 2 કે 3 લેક્ચર છે.
અચ્છા, ખાલી લેક્ચર જ છે.
હા
ઓકે, અને એક તો મારો જ લેક્ચર છે એમાં.
સર 3 જ લેક્ચર છે, ટ્યુઝડે ના 3 જ લેક્ચર છે. 1:10 અમે ફ્રી થઈ જઈએ છીએ.
1:10 તો ના હોય. ઓકે, 1:10 જ ફ્રી થઈ જાવ, બરોબર છે. ધેન એક ટ્યુઝડે રાખી દઈએ આપણે. એન્ડ સેકન્ડ વન ઇઝ માય લેબ ઓન થર્સડે. સો સેકન્ડ ઓપ્શન ઇઝ થર્સડે.
સર આપણે એક કામ કરીએ, ફ્રાઈડે સેટરડે રાખી દઈએ તો સર, તો મારે પણ કામ થઈ જાય. તો ફ્રાઈડે સેટરડે અને સન્ડે પછી એવું હશે તો મારે નાના ત્યાં જતો રહીશ.
અરે એવું ના થાય પાંચ. બધા જણનું અરેન્જમેન્ટ કરવાનું છે એક સાથે. સો ટ્યુઝડે એન્ડ થર્સડે વુડ બી બેસ્ટ ઓપ્શન. બરાબર છે.
થર્સડે નહીં રાગા, થર્સડે તો બહુ બધા ક્લાસ હોય છે. ફૂલ
હા
ડે.
સર,
થર્સડે થર્સડે
આપણી લેબ છે એમ ને?
sir, and if we are coming from Ahmedabad, we have to travel while attending the lectures.
સોરી.
When we are coming from Ahmedabad, we have to travel like while we are attending the lectures. We have to
What
travel.
you can do is you can come in the morning at like before 9:10. Your buses are already running,
બ્રહ્માની ને એમાં
and you can come here once, and then from here, like from sitting in the college, you can attend the lectures. Once you are done with your lectures, you can come to the lab and we'll start the lab session.
Okay, sir.
વાંધો નહીં સર, અમે એકવાર ગ્રુપમાં ચર્ચા કરી લઈશું, બરોબર? પછી તમને કોલ કરીને જણાવી દઈશું.
But do it by today. Do it by today.
ઓકે
જો
ઓકે
કાલે લેક્ચર રાખવું હોય તો મને આજે જણાવવું પડશે તમને.
ડન સર.
બરાબર છે. ઓકે, તો જેટલાને સમજ પડતી એના માટે હું હવે આગળ વધું છું આ લેક્ચરમાં. બાકી બધાને લાઈક જેટલું બને એટલું વહેલા આપણે આ શેડ્યુલ એટલા માટે કરીએ છીએ because you can understand like what is the issue, like how to solve the programming. એટલે ક્વેશ્ચનને સમજીને જે પ્રોગ્રામિંગ આવડવું જોઈએ નહીં આવડે ત્યાં સુધી હું ગમે તેટલું આગળ જતો તો તમને કંઈ કામ નહીં લાગે. પછી હું મારા સાઈડથી કોર્સ કમ્પ્લીટ કરી દઈશ, બટ યુ વિલ બી બેક. તમે લોકો પાછળ રહે. સમવન હેઝ ટર્ન ઓન ધ કેમેરા એક્સિડન્ટલી, પ્લીઝ ટર્ન ઇટ ઓફ. સો એ તકલીફ થઈ જશે. સો એટલા માટે હું ટ્રાય કરું છું કે જો કાલે જ થઈ જાય દેન ઇટ વુડ બી બેસ્ટ. અને જો કાલે થઈ જતું હોય દેન વોટ આઈ હેવ એન ઓપ્શન ઇઝ, મારો જે ફર્સ્ટ લેક્ચર છે એ હું કોકને આપી દઈશ, જેનો જે થર્ડ લેક્ચર છે એને આપી દઈશ. સો હિલ ટેક ધ ફર્સ્ટ લેક્ચર. બીજા જેનો લેક્ચર છે સેકન્ડ ડે સેકન્ડ લઈ લેશે. દેન વી વિલ હેવ લંચ એન્ડ આફ્ટર 12:10 આઈ વિલ બી સ્ટાર્ટિંગ વિથ ધી 805. એટલા માટે હું કાલે સજેસ્ટ કરું છું બીકોઝ કાલે એક મારો બી લેક્ચર છે તો એ અરેન્જમેન્ટ થઈ જાય. અને સેમ એક થર્સડેના ઓપ્શન છે એવો. સો થર્સડેના હું કોઈ જોડે લેક્ચર એક્સચેન્જ કરી શકું છું, એનો કોઈ ઇશ્યુ નથી. બરોબર છે. સો દેટ્સ વાય આઈ એમ ટ્રાઇંગ ટુ શેડ્યુલ ઇટ ટુમોરો. Okay, that's my first target. But please do discussion and let me know whatever is convenient at your end. Okay. But other than that, let's start this program. Okay, where? Yeah. Okay, so this is how we run the time. Now the thing is that we are receiving the pulses from this bottle and we have to count the 100 bottles. Okay, so again that same principle comes here. If I want to reach at the 10th step and if you have allowed only 5 step move, you have to start from 5th or 6th step, then on your final step you like 5 steps you will reaching to 10th. So same way here we have applied the same logic and we have calculated a number that is 9b to be loaded in your timer resistor. Okay, so rather than taking a 100 bottle count, I will go with 10 because the issue with the 100 bottle count is that it is not possible to count the 100 bottles. Like I have to click 200 times to insert that thing. So we'll see an example with 10 bottles. Okay, but in programming you have to write it 90. Okay, so right now I'm just going with 10 bottles. So I'm writing 255 minus 10 here. Please do not write it like this. I know that will work, but it won't work for 16-bit mode. That's why I'm letting you know. Okay. Then what I'm going to do on the 100 bottles received, I will generate a timer overflow flag. So I'm going to use it as an interrupt. So I have to program the interrupt first. So I'm going to write E is equal to 1, that is global enable bit, and ET0 is equal to 1, that is local enable bit of your timer. Okay. Now, as I have enabled the interrupt, I have to write a subroutine. So I'm going to write void timer 0, not 0, this is timer 1, ISR, or let us say void counter ISR. You can say it as a counter as well, no issue in that. Okay, then you have to write a special keyword, that is interrupt. This is a special keyword and followed by a number. Which number? Again, the same principle, 0, 1, 2, 3, 4, only 4 options. I am working with timer 1, so I have to write number 3. What I have to do, if I generate, I have to send a signal to pack machine. So let us say pack machine is equal to 1. I have to send a small pulse. Okay, small pulse, that means it should be like 10, like 1 millisecond pulse. Okay, so what I'm going to do, that I'm going to do it like for I is equal to 0, I is equal to 250, sorry, is then 250. I'm wasting my time here because I should send a signal which should be 1 for some time, and then I'm going to move back to 0. Now let's run this program and see what happens. Let us say packaging machine is connected on pin P1.0, so I'm going to write 0x90. Where is the error? I am not able to find out the error. Yeah.
P80255 minus 10 પછી
AC,
semicolon ગયો.
yeah, correct. Semicolon is there. Now I have to put the errors. S bit LED. Okay, this is not the way to write it. Okay, I is undefined and I can select content. Okay. Now where is it missing?
Sir, CHAR.
CHAR. Correct. CHAR. Still there is a error. Okay. Based on the color. Now see what will happen. I'll have my pack machine over here. Let me set up a pack machine. Where is it? Where is it? And I'm going to run this. Yeah, please close. And I'm going to. Okay. Now see what I'm going to do is I'm going to send a signal from this pins. Before that I have to run this. Yeah. Now I'm going to send a signal from here. Okay. It is counting. See, it is counting. Why it is started with 0 0. Yeah. So I have to write TL1 and TH1 here, so keep that in mind, and ET1 here. Even I can do this kind of mistake, so you have to closely look at your program, what you are doing. Okay. Okay, now the program is running. Now what I'm going to do, I'm going to send a signal from this pin. So you can see here it is number is incrementing. It is started with F6. Okay, F7, F8, F9, F8. So as I receive the pulses, see now overflow will happen and अरे यार मोड सेटअप करना चाहिए. I should be not writing 50 here, but I should be writing 60 here. I I have messed it up over here. See, this is mode 1 and not mode 2. We should be writing mode 2. This is wrong. This is wrong. It should be mode 2. 8-bit auto reload is mode 2 and not mode 1. So your number will change. It should be 10 and this is not 50, it is 60. Okay, so 60 is the number. 7 control F5. Now everything should be working as it is. Yeah, okay, it is working as it is. See, now I'm going to apply some pulses over here and see a pulse appeared over here. Okay. Now again I'm going to do it. Now due to some internal error, not internal error, I know what happened there, but I'm going to show it again. Okay, see, now you can see this is a pulse. I'm going to stop this program. Stop. Yeah. And I'm going to zoom in. So you can see the pulse. This is a pulse, okay? Because my time scale was very large, that's why I was not able to do that, see that. Okay? Because this is in microseconds. It's 0.9 millisecond signal, okay? Or almost one millisecond signal, you can say. So the LED is going high for 1 millisecond. Each time you receive 100 bottles. Right now, in this case, it's 10 bottles. Why I have selected 10 bottles? Because I have to send a signal from here like this. So when I send a signal like this, if I want 100 bottles, I have to turn it on and turn it off 100 times. So that's 200 times. So that's why I have taken a small number. But if you want to program for 100 bottles, you should write 9B over here. Okay. So this is the program and this is how it works. Okay. It is sending a signal to your packaging machine each time you receive the 100 bottles. Okay. Now next count can start. So I'm going to quickly do that. See how it will look like. See, each time it's received the 10 bottle, it is sending a pulse. Okay. You can see this pulse over there. So this is the way how a counter works. So counter is working in background and whenever it sees the event occurring, it is sending a signal. Okay. This is the program for a counter. Now I'll give you a two task. If you can do it, that's fine. If you cannot do it, that's also fine. But if you can do it, I'll be happy. I just want to check who are able to do this kind of programming. Okay. So we'll stop here for the today's lecture, but let me complete that. Let me first stop the recording.